characteristic needs to be expressed somehow. That expression is what is actually representation, right? So if your concept is weight, then the representation, what is it? It's a number that describes the weight. It could be 85, it could be 190, right? But to actually understand what that means, you also need a unit of measure. 85 kilograms is about 190 pounds. So, what are the three types of representation possible in SDMX? Coded, formatted, and free text. Perfect. Now you tell us about what these three things are. Coded and formatted and free text.
Coded is we have an ID. We must have a standard ID and a label. And for free text, example like string. Yeah. And for what? I'm sorry for the last. Coded, formatted like time format, date.
Yes. Basically, thank you. Coded, that means that a concept has a code list attached to it, right? What is a code list? It's a list of codes, just as it says. Basically, what it means is that the concept is enumerated, because a code list lists every possible value that a concept can take. Then we have a formatted value or typed value. In that case, it's basically you specify a data type. It could be a string, it could be a floating point, it could be an integer value, and then you specify the format for that. Well, integer is an integer. It doesn't matter. You can even add a format to that, but integer is sufficient. So then you don't enumerate values, but the concept can take whatever value is allowed by its format. And then finally, free text is free text. There are no restrictions on the value of the concept. So, what are the two representations that a dimension can take in SDMX? We have three representations. Code, format with type, type with format, and free text. Format, yes. Formatted value or a code list. That's right. A dimension can be either you specify a type and a format for a dimension, or you specify a code list. And attribute, with attributes there are no restrictions. Yes. Great. Speaking of which, what actually is the difference between dimension and attribute? Yes? Farhan, you would like to say that? What is the difference between dimension and attribute?
Dimension represent the data, and attribute additional information to describe the data.
Yes, thank you. Dimensions are used to identify observation, and attributes are used to supply additional information about the observation. Dimensions are really like coordinates. if I tell you, find a person in this room with black hair, can you find that? Can you find the person with black hair? No. That's right. And if I tell you, find a person who sits in row 1, desk 4, counting from the left, can you find that person? Yes, Amani. Amani is the person. So what does it mean? The row, is it a dimension or attribute? Row, it's a dimension. Desk number, is it a dimension or attribute? Dimension. Color of the hair, is it a dimension or attribute? It's an attribute. That's the difference between dimensions and attribute. Dimensions help you locate, identify an observation. Attributes supply additional information. They are not used to identify an observation. In real life, it's not always easy to specify which concept should be a dimension or which concept should be an attribute, but we're not going to discuss the unit of measure again. Trust me, what we had yesterday is nothing like the discussions that take place in other fora regarding the unit of measure. All right, anyway, so then we did the exercise, and what we did was, where we stopped was we completed exercise 1A. That is, we looked at a data set, we listed concepts, we identified their roles, and for attributes we identified the attachment level. By the way, what's an attachment level? Yeah, but what is? The thing is that, again, dimensions always apply. Yes. The dimensions always apply to each individual attribute. Dimensions always apply to each individual observation. Row, desk number, always apply. But attributes, they may not apply. I mean, they can always apply to an individual observation, but they can also apply to groups of observation, right? For example, suppose that we had participants seated by country, so that Bhutan is in the first row, Brunei is in the second row, and Indonesia are in the other rows. In that case, can you attach the country to each individual participant? Yes, you can. But you can also attach the concept to the row. If we know that participants, a row can only have participants from a single country. And in that case, that attribute applies not to individual participants, but to the entire row. Can you apply this attribute? Can you attach it to individual participants? Yes, you can. But it's more efficient to attach the attribute to the entire row, because then the information is only transmitted once for the row instead of every time for individual participant, right? And last but not least, by convention, not even by convention, by common practice, up to and including SDMX 2.1, attributes are attached either to observation or to time series or to a data set, but to a data set that is less common. So most of the time attributes are attached either to observation or to time series. When an attribute is attached to time series, that means it's attached to all dimensions except time. Right? So if we are attaching an attribute to the row, then we only attach it to the row dimension. We don't attach it to the desk dimension. Right? If you have two dimensions, one is row and the other is desk, you don't attach the country to both of them. You only attach to one of them, right? It's a dimension group. In the case of statistics, in the case of SDMX, when you attach an attribute to a group of dimensions which includes all dimensions except time, then essentially you're attaching it to the time series. And we'll talk about time series soon. But now let's come back to our exercise. Rehan, I shared application. Great, thank you. So we decided that we will ignore the concept indicator because it's a bit confusing in this case. And we identified concepts: series, reference area, age, sex, time period, observation value, unit of measure, unit multiplier, source, and observation status. And we actually we also added concepts frequency and observation status, even though they are not present in the data. It's an established practice in SDMX to always use those two concepts. And frequency is always, again, a dimension, whereas observation status is an attribute. So what do we do next? What do we need to do now? I'm listening. Well, it's in the exercise manual, exercise 1B. We found out concepts, we found out their roles. Now we need to determine representation. All right. Frequency, what do you think its representation should be? Code list, and we'll name it CLFrec. It's a cross-domain concept and a cross-domain code list. Series, code list. Rehan, do you have a stand for the microphone, because it's a bit difficult to type? Reference area, code list, cross-domain concept and cross-domain code list, CL_area. Age, code list, CL_age. Sex, code list, CL_sex. With the exception of CL_series, the remaining ones are cross-domain concepts, cross-domain code list. Oh, okay. Yeah, it's fine. Observation value. What's the representation for observation value? Floating point number, perfect. Unit of measure. Code list. Unit multiplier. Unit mult. Source. what should be on the CL frequency? What should be on the CL frequency code list? Remember I told you. Thank you. Remember I told you that CL frequency is a cross-domain concept and CL frequency is a cross-domain code. Where do you find cross-domain codes? At the SDMX global registry. So instead of reinventing the wheel, let's just visit the SDMX global registry and see what we have there. Okay, I'm trying to share. Just 1 second. Here. Yep, great. Registry.sdmx.org. Remember that address. The SDMX global registry. So how do we find the code list? We go to items and we click on code lists. There we have our code lists. Now, see this drop down that says all? These are so-called maintenance agencies. We'll talk about that in more detail a little bit later. Cross-domain code lists are identified by agency SDMX. And there we have it, CL frequency. And if we view the code list, this is the, these are our codes and names. And this is what we need. Code, the annual frequency has code list A. Okay? So let's just write down that alright, let me share my screen instead. Just 1 second. So for the code list CL frequency, we'll say that code A, name is annual. And obviously the code list is longer. You also have quarterly frequency, monthly, weekly frequency. But let's just say that the one that we only have annual data, as you can see. And let's say that we only need one code from that. CL series. I'm going to cheat here a little bit. CL series is not cross-domain code list. But I happen to know that it's used by, and these series are from the SDG data structure definition. So I'll take codes for this series from that code list. Again, in order not to reinvent the wheel. So I'll go to the SDMX global registry. Let's see what we have here. CL underscore series. There it is. The CL series code list maintained by the Interagency and Expert Group for SDG indicators. Let's have a look at this code list. It has 815 entries. We don't need all that. We'll just say number of deaths and missing persons attributed to disasters. Alright. Let's find it. Number of deaths and missing persons attributed to disasters. Number of death and missing persons attributed to disasters. Is that the one that we need? Yes. Okay, great. So let's say this is our code list, and this is our code. So we're going to use this code. Number of death and missing persons attributed to disasters. And the second one is employed population below international poverty line. Now we have to be careful. Employed population below international poverty line. There we have it. Great. Reference area. I'm going to cheat again because I remember reference area codes. For Kyrgyzstan, the ISO 2 code is KG. And for Thailand, the ISO code is TH. And if you go to the global registry and you find the code list, you will see that these are the correct codes. What else? Age. So tell me, which codes do we need for age? I mean, to begin with, let's list all the, without listing the actual codes, let's see which entries we need to put into the code list. Give me the names of the codes first. 15 to, right, and 15 plus, 25 plus. Is that all? What is age for this first line? For the first and second row. What is age here? That's a good answer, but that's not the only possible answer. The thing is that depending on your practice, depending on your assumption and point of view, the row, the age for the first row can be either total or not applicable. And that's, if you start discussing total and not applicable, then you can spend even more time than in the case of the unit of measure. But yes, depending on how you approach this, age for the first row could be either total or not applicable. It could be total because they indicate the number of death and missing persons attributed to disasters. It can be broken down by age. So it's correct to say that this is total. But then again, it isn't actually broken down by age. So some people argue that because it's never broken down by age, it's not applicable. There is no right or wrong answer here. So let's say that let's introduce both codes. We will use both total and not applicable. And what is the code for the first row? Okay, we are running behind the time slightly, so let's just save the time. There are certain rules how to create H codes. I'm going to use the SDG code list. And let's just do it quick.